Double angle identities. These are the double angle identities. And the reason why we call it double angle identities because you are getting the cosine of twice an angle. Cosine of 2 times alpha. Here, you are getting the sine of twice an angle. It's sine of 2 times alpha. I'm not going to prove this. You will prove this on your own. You know, one of the genuine satisfaction that we get from math is when we are able to prove theorems and identities on our own. And I do not want to take away that satisfaction from you. So try it. Prove these double angle identities on your own. And I will give you a hint about how to begin. Usually students are enthusiastic to prove, but they just don't know how to begin. Okay? So I will give you something, a clue, and maybe you can use this to help you begin your proof. So cosine of 2 times alpha, that is just equal to cosine of alpha plus alpha. 2 times alpha is equal to this, alpha plus alpha. It's the sum of 2 identical angles. So you know now what to do, okay? So instead of proving the double angle identities, I will prove other identities. Let's say, for example, this one. Prove that the square of sine of x plus cosine of x is equal to 1 plus sine of 2x. So this one requires our double angle identity for sine. Sine of 2 times x is equal to 2 times sine of x, okay, times cosine of x. Okay? Okay, so where did this come from? Okay? Well, this one is applying our special products on sine of x plus cosine of x. Okay? And this is equal to a squared plus 2 times a times b plus b squared. So you will square the first term plus 2 times the first term times the second term, and you will square the second term. So this one is just the direct application of your special product. Now, just in case you are the sort of student who managed to enroll in Precal and cannot do the special product, what you do is you just multiply this term by term, okay? Now, so let us pay attention to these terms. So this one is just sine of 2x. Okay? This is sine of 2 times x. That is one of our double angle identities. And how about this? What is the square of sine of x plus the square of cosine of x? Well, we know that to be equal to 1. Okay, so this one is equal to 1 plus sine of 2x. So that's it, we are done. How about this one? Cosine of x raised to 4 minus sine of x raised to 4 is equal to cosine of 2 times x. So this means this should be listed among your double angle identities. Okay? So at the first glance, it just seems so intimidating. But if you are patient in thinking, if you have that fortitude in you to think this through, this again is something that requires your special product. Okay, so let us go back to a minus b, okay, times a plus b. What is this equal to? We have a special product for this. This is a squared minus b squared. Now look at the pattern, okay? Look at the pattern. So this means that if I have something like a squared minus b squared times a squared plus b squared, okay, I can apply this special product. This is a squared and square again minus b squared and you square it again. And what is this equal to? It's equal to a to the fourth minus b to the fourth. Okay, so why did I do this? Because I want you to see what you can do with this expression. Okay, so this means that this is equal to this. The square of cosine of x minus the square of sine of x times this one. And you know what this is equal to, okay? That's just equal to 1. And we have a double angle identity for this. This, in fact, is equal to cosine of 2x. So, we have shown it. This is equal to cosine of 2x times 1, or simply cosine of 2x. Prove that 1 plus cosine of 10 times x is equal to 2 times the square of cosine of 5x. Okay, we were just talking about double angle identity, and then all of a sudden we have something like this. And so you can now see why this is listed as an exercise under double angle identities. Because look at this. 5x, 10x. So 10x is twice of 5 times x. 2 times 5, okay? 2 times 5 times x is equal to 10x. So you can see here the logic why this is listed as an exercise under double angle identity. Okay, so we will write this as cosine of 2 times 5 times x. So you can now look at this as cosine of 2 alpha. Okay? And so we will apply your special angles. No, we will apply our double angle identity for cosine of 2 times alpha. So applying our identity, it becomes 1. Okay, so we just copied this. 1 plus this. Okay, look at that. 2 times cosine of 5x raised to 2, and then minus 1. And then we will simplify it. 1 minus 1 is 0, and so we are left with 2. We are left with 2 times the square of cosine of 5x. So we are done.